Okay. So on part C, what kind of triangle do we have to be looking at here? 45, 45, 90. So I'm going to sketch that out real quick. So we have our right angle here. These two sides are congruent. 45 and 45. All right. So on any triangle, we have three sides and three angles. We know all of our angles now, right? We know that angle A is how big? 45. Angle B is 45. And they told us from the very beginning that angle C was 90. One thing that I did want to take a moment to address, just because you'll see it show up sometimes, especially in the textbook that you guys have. Sometimes for angle A, instead of using A, they're going to use alpha. Instead of B, they're going to use beta. Instead of C, they will often use gamma, just because those are the first three letters of the Greek alphabet. Just like we go A, B, C, they have alpha, beta, gamma. So if you see those are interchangeable with our angles A, B, and C. All right, so if this is A, this is B, this is C. What's the relationship that we know with a 45, 45, 90 on the sides? Yep, my two legs are going to be congruent, so a lot of times we'll call these X, even though they told us that this is 5 in this triangle. What's the relationship between those two legs and the hypotenuse? Yeah, it's going to be x square root of 2. So when we're talking about our three sides, they told us that A was 5. They told us that B was 5. So how big is side C? 5 square root of 2. So there's those three other pieces that we needed. You guys okay on this example? All right, let's go look at example D. Is this one a 45, 45, 90? It's still a special right, though. What kind of special right is this one? 30, 60, 90. So I'm going to draw 30, 60, 90 here. We know that our right angle is here, and I know from what they told me that that's going to be angle C. Three sides, three angles. Now with a 30, 60, 90, what are the relationships with the sides? We've got a long leg and a short leg and our hypotenuse. What are the relationships between those? Yes. So if I call the smaller leg x, then the hypotenuse would be 2x. That's absolutely correct. What's the relationship then with the long leg? Yeah, it's going to be the short leg times the square root of 3. So we would call this x square root of 3. So knowing those relationships right there, they gave me side B and C. C is going to be which part? Long leg, short leg, or hypotenuse? Hypotenuse. So this over here is 10 square root of 3. Is side B the short leg or the long leg? Is side B the short leg or the long leg? How do you know? Because it's half as big. So this is going to be 5 square root of 3. So this is my side B, which means this is angle B up here because it's across from side B. So down here would be angle A. Let's fill in our 3 angles then, because I don't know how big angle A or B is, but we know that this is a 30, 60, 90 triangle, right? So is A the 30 or the 60? The 60. A is going to be our 60-degree angle. Which means that B is our 30-degree angle. That leaves just one piece of this triangle left to determine. We need to figure out how big side A is. How can I determine how big the long leg is? That's absolutely correct. We're going to take the small one, which is side B, and we're going to multiply it by the square root of 3. So I'm going to take 5 square root of 3 times the square root of 3. Square root of 3 times square root of 3 is what? 3. So I have 5 times 3, which means 15. So side A is 15 units long. You guys okay with that so far? You've got to learn and remember your relationships on your special rights. Mainly which one gets the root 3, which leg gets the root 3, which leg is the 2x, and in which kind of special right do we have square root of 2. Those would be the types of things that you need to pay attention to. All right, we're going to transition from here into applications, into story problems. So we're going to spend most of today reading through these stories and drawing pictures. So if you look right down there at problem number 2, part A, should say airplane landing. I hope you guys like bad art because I am full of it today. We're going to draw pictures to understand what information they've given us. We're going to use that information to draw a triangle, and we're going to be looking at which of our trig functions will help us solve for what we're looking for here. All right, so it says airplane landing. A pilot flying at an altitude of 5,000 feet wishes to approach the numbers on a runway at an angle of 10 degrees. So I'm going to start my really bad picture with a whale of an airplane here. And the airplane is flying along like this. So tell me what's going on with the story that I can use to continue drawing here. 5,000 feet. What does it mean for it to be at an altitude of 5,000 feet? Above the ground, like a perpendicular distance to the ground, right? So I know from right here to right here, we're at 5,000 feet. All right, what else do we know? 10 degrees. So where would that 10 degrees be? Like if you're the pilot,
The bottom right.
bottom right. So somewhere down here? Yes. I want you to think about yourself as the pilot on the plane.
Would it be right under the airplane?
Yeah. What you said is not wrong. I can go point to an angle that would be that exact same degree. So this right here is 10 degrees. And here's the runway. Let me get just a little bit of notation here. This right here is called an angle of depression. So if I'm looking across like a horizontal and I have to look down to get to what I'm aiming at, that's an angle of depression. If I've got a horizontal and I look up, that's an angle of elevation. So the angle of depression that the pilot would cite to get down to the runway, that's going to be exactly the same as the angle that a person on the ground would have to look up to see the plane. And I think that's what you were getting at there, Alex. So technically it's the same angle, but since the story is talking about it from the perspective of the pilot, I'm going to stick with that. But you can get the same answer kind of approaching it slightly differently. All right. How do I make sense of this? What can I do with this? What are we looking for in the problem?
The distance from the airplane to the numbers.
So would that be this? Would that be this? Would that be this? Like, what is it that we're actually wanting to know? Which one? The red, yes. This is what we want to know. What's the actual distance the plane has to travel to get from where it currently is to being on the runway? We know the angle that he needs to aim the plane at. I need to make a triangle out of this. I don't actually see a triangle yet. What did you see?
We need the bottom.
We either need the bottom, so we can either do this, or does anybody else see something else that I could do?
On the
Yeah.
side.
This right here, right? Do we know that distance?
Yeah.
How big is that? That's 5,000 feet, right? That's exactly the same as over here, which I think I actually need to take that up just a little bit. There we go. This is 5,000 feet. Because if he were to continue to fly like this and go right over the airport, right over the runway, he'd be 5,000 feet above the runway, right? What trig function would help me figure this out? Sine. Why sine? Opposite over hypotenuse. We're going to use sine of theta, because that is opposite over hypotenuse, or we can think about that as y over r. Do we have an angle to put in for theta? 10. So I have sine of 10 degrees equals, do we have a number that we can put in for the opposite? 5,000. What about the hypotenuse? X, that's the thing that we're looking for. Talk to me about how I can find X. Sorry, one more time. I just didn't hear you.
You multiply by the x to move it over to the left side, and then you divide by sine.
Yes. We're going to multiply both sides by x. That'll cancel out there, so I'm going to have x times the sine of 10 degrees equals 5,000 feet. Divide both sides by sine of 10 degrees. You are going to need a calculator for this. you do need to make sure that your calculator is in degrees mode. If you grab one of my yellow ones, because we used these earlier today, they should be in degrees mode already. If you have your own, just look up at the top, very, very top. It either has the letter D or it'll say DEG if it's in degrees mode. If it's in radian mode, it'll either have an R or an RAD. I can show you how to switch between the modes if you're not in degrees mode already, but please make sure that your calculator is in degrees mode. You are welcome to come and borrow one of mine if you need to. What are we getting when we do 5,000 feet divided by the sine of 10 degrees? You said 28,793 point what? 0.85. Would we have units with that? Feet. All right, so let's read the directions, because if they want us to round it all, those directions would be up with the text. Did they want us to round our answer? It says to the what? To the nearest 100 feet. So here's the hundreds place. It's 793. So if I wanted to round to the nearest 100, would I do 28,700 or 28,800? 28,800. So X is about 28,800 feet. Do you guys have any questions about that one? Okay. Let's go look at part B. Surveying. Oh, you guys get to see more of my wonderful pictures. To find the distance between 2 points, P and Q, on opposite shores of a lake, a surveyor locates a point R that is 50.5 meters from P, such that should be segment RP, is perpendicular to segment PQ. Next, using a transit, the surveyor measures angle PRQ as 72 degrees 40 minutes. Find the distance D. What should I start my picture off with? A lake. All right, so here's my wonderful lake. What else do I need in my picture? P and Q. Where should I put P and Q? Opposite sides, okay. Does it matter whether I go side to side or up and down? Not really. I'm going to do them like this. So here's my point P. Here's my point Q. What are we calling the distance between them? D. It says find the distance D. We have another point on here, don't we? R. Where should I put R? Up. Directly above what? Like, can I put it right here? Directly above P. It says that locates a point R that is 50.5 meters from P, such that RP is perpendicular to PQ. So here's R. Can I label anything else on here? What'd you say?
The distance between P and R.
Yes, the distance between P and R. We've got 50.5 meters. What does our surveyor do next? Yes. This angle R right up here, that is 72 degrees 40 minutes. What trig function is going to help us out here? Tangent. Why tangent?
Once you grab one side and you need to find the other side.
Yes. Tangent is opposite over adjacent, or we can think of this as y over x. Which part of this do we know? Do we know our adjacent side? Do we know our opposite side? We know our adjacent side. We're trying to find our opposite side. There's only one little issue that I see with the information they gave us. They said my angle is 72 degrees, 40 minutes. How do I put something like that into my calculator? Yes, we want to convert this to just decimal degrees. How do I do that? Divide by what? 60. We're going to take this and divide by 60 so that we can put it into just decimal degrees. So it's going to be 72 point what? Yep, it's going to be 6 repeating, right? Let's take that out to 3 decimal places when we're putting it into the calculator. So we're going to have 72.667 degrees equals d over 50.5 feet, or sorry, 50.5 meters.
Why did you have to take that out so far?
Why did we take it out so far? Because we want to go for precision. If they don't tell us where to round, standard is you take it out 3 places unless they say otherwise. Because I don't always know how much of a difference in my final answer rounding is going to make. Where do I go from here? Multiply both sides by 50.5. So what I'm going to put into the calculator is 50.5 times the tangent of 72.667. And what do we get? 161.8 meters. So this is approximately 162 meters, right? On the homework for this, which by the way is due Thursday, I will tell you what I want you to round to. If in the event you read through the problem and you do not see what it wants you to round to, default is 3 places after the decimal point. All right? Do you guys have any questions about this one? Yes? Oh, okay. You were just playing with your mask? Okay. Let's go look at part C then. What do we have going on here? We've got the sun. Okay, so I'm going to need to get an orange color out here. And what's going on with the sun? What's happening? It's casting a shadow. So, question, if our person is standing right here, is the shadow going to be on this side or on this side? That side over there. Okay, so here's my person, and here's their shadow. What do I know about the person and the shadow? Person is 5 feet tall, and the shadow is 4 feet long. Do the person and the ground make a right angle with each other? Yes. What do I want to know in this problem? The angle of elevation. What is the angle of elevation? Yes. So this would be if there was an ant on the ground looking up to the top of the person's head, they should see the sun just like right at the top of their head. So we're looking for this angle right here. I'm going to call it alpha. And that's what we're looking for. What trig function is going to help me find alpha? Tangent. Why tangent? Yes. Tangent of alpha is going to be equal to my opposite side over my adjacent side. How big is my opposite side? 5 feet. How big is my adjacent side? 4 feet. Do you notice anything that's going to simplify there? Five over 4 won't simplify at all. What else is part of those expressions? Feet. Feet divided by feet would be? Nothing. Cancels out. It becomes a 1. So then I have tangent of alpha is equal to 5 over 4. Tangent is a function. It's a thing that happens to our angles. I want to undo it so that I can find alpha. How do you undo multiplication? With division. How do you undo subtraction? With addition. Those operations are inverses of each other. They undo each other. To undo a trigonometric function, I have to use the inverse function. So I need not the reciprocal. Good idea. Not the reciprocal, though. I want the inverse function of this, so it's tan inverse. It has that little -1. Do you guys remember inverse function notation? That's exactly what we're using here. And if you do it to one side, got to do it to the other side. So we're going to use the inverse tangent of 5/4, because that's how I get alpha all by itself. What is inverse tangent of 5/4? How much? 51.34 degrees. All right, so now I have a challenge for you. I want you to take that answer right there. Since your test is coming up in just a little over a week, it's a week from tomorrow. I want you to convert that into exact degrees, minutes, seconds, rounded to the nearest second. So I already know it would be 51 degrees. How many minutes? 20 minutes. How did you get that? Times 60. What did you times by 60? 0.34 times 60. And you got 20 exactly? 20.4 minutes. Okay, so how many seconds? How many? 24 seconds. And how did we get 24 seconds? 0.4 times 60. And that gave us 24 seconds. Beautiful. Do you guys have any questions for me on this one? All right. Let's go look at another one. Ethan, you look so excited.
Yes.
Conveyor belt. A conveyor belt 9 meters long can be hydraulically rotated up to an angle of 40 degrees to unload cargo from airplanes. What are they talking about? Hydraulically, what are they doing? Can anybody explain to me before we read any further in this problem? They're unloading cargo. How high off the ground are airplanes? High. A lot higher than it looks, right? Like when you get up close to them, these things are enormous. So they have this conveyor belt that is on like this little truck platform that they can drive out or usually pull behind something. And this bit here can be lifted up. And so they have this like little hydraulic lift thing here to raise that up so that then they can just, somebody on the inside, throw the luggage onto the conveyor belt without destroying everything. It'll go down the conveyor belt and go onto the little tram so that they can take it to your luggage pickup. When they say that this conveyor belt is 9 meters long, are they talking about this part or that part? Which would be what part of my triangle that I'm getting ready to build? That's my hypotenuse. This is what is 9 meters. And I know it eventually straightens out, but the part that can be lifted is the 9 meter part. Okay? What else do I know in this picture? It can go up to 40 degrees, right? Is this one fully extended? Or do we know that? We don't know that. We know that's the maximum it can go, because more than 40 degrees, and it's too much. You're going to have stuff sliding down and actually causing damage. So what else do I know for sure about this scenario? What'd you say? 4 meters above the platform. So remember, this conveyor belt is like on a truck bed right here. So right here, up here's the door that they're unloading it from. I know that this distance is 4 meters. There's my poorly drawn door. I'm not drawing all the rest of the airplane that goes with it because you guys have already seen my art skills with an airplane. What do I want to know about this problem? I want to know the angle of elevation, yes. Find the angle. So what function is going to help me do that? Here's that angle that I'm looking for.
Inverse of sine.
Inverse sine, yes. Because I have sine of my angle theta is going to be equal to what over what? 4 over 9. 4 meters over 9 meters. Meters is going to cancel. I need inverse sine. So what is inverse sine of 4 over 9? 26.387. Did they want me to round at all?
Yes.
What did they want me to round to?
Degree.
Nearest degree. So is this 26, 27, 25? Like, what are we doing? 26 degrees. So this thing is definitely not fully extended. What is the maximum height this thing could get to if it was fully extended? What would help me figure out the max vertical height if the conveyor belt is fully extended.
Sine 40 equals x over 9.
Yes. We would do sine of 40 degrees, because that's full extension, is equal to x over the length of that conveyor belt isn't changing. It's going to stay 9 meters, right? So then how do I solve that?
Sine 40 times 9.
Yes. Sine of 40 times 9. Let's take this one out to 3 places. What is the highest this could go?
5.785.
5.785 meters. That would be the max vertical height. So it can't be more than, 5.5-ish feet off the bed of this little trailer thing with the conveyor belt. We're going to do part E tomorrow. So we'll pick up there.